1973, number 13. So A of t, I'm going to define it as a instead of alpha. That's my acceleration, 8 minus 6t. Now the velocity, they tell us the velocity is 25 when t equals 1. That means v at 1 is 25. And what do they want? They're looking for s of 4 minus s of 2. But what is s? S is the position. So s is the position function. So technically, v, I'm going to rewrite this. V of 1 is the same as s prime at 1. No, sorry, s prime at 1. It's 25. Okay? And let me just do general stuff. A of t is v prime of t, or it's s double prime of t, right? Just as a reminder. So that's the relationship between the three. So I have acceleration. From acceleration, I can find velocity. So the derivative of velocity is acceleration. Therefore, the antiderivative of acceleration is velocity. So velocity is the integral of the acceleration. All right, acceleration is 8 minus 6t. I'm leaving gaps. I think I just have to restart this program, but I won't do that right now. So the antiderivative of 8 is 8t. The antiderivative of 6t is negative 6t squared over 2 plus c. Don't forget your c. Whoops, that's not a c. Whoa, 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 whoa. Whoa, whoa, bad things are happening. Don't forget your plus c or you will be very sad. Because, and a reminder of why if you forget, the derivative of any constant is 0. So I could have any number there, take the derivative, and I end up with nothing there. So it could be any c. We can't assume it's 0, and it's not in this case. But look at here, initial value. We're told when we plug in 1, it equals 25. So that's what we're going to do. V of 1 is 8 times 1 minus 3 times 1 squared plus c. And we know that equals 25 because they told us so right there. Well, 8 minus 3 is 5. Subtract 5 from both sides. We know that c that we found is actually 20. So what do I know now? My velocity function is 8t minus 3t squared plus 20. Let me lower this down here. Whoops. Yeah. So now I have velocity, but here is the important thing. What are we looking for? S4 minus S2. Let me remind you of the fundamental theorem of calculus. The fundamental theorem of calculus says if I take S prime of t from 2 to 4, that's going to be, oh, why does it do that to me? I don't understand. That, by the fundamental theorem of calculus, is S of 4 minus S of 2. Okay? A reminder, the antiderivative of that is S. Then you plug in 4 and 2 and subtract. So again, back to the fundamental theorem to make the big connection. If you integrate S prime, it gives you the change in S, because that's the change in S. The final S minus the initial S is the change in S. But this is what we're trying to find. Look, it's asking for S4 minus S2. So I just have to find that. But what's S prime? The derivative of position is velocity. So what it's really asking for is the integral of velocity. Wow, this is actually a pretty tough problem. Like, if I gave this, I would expect half the people at least to get it wrong. Probably more than half I'd expect to get it wrong because there's so many steps. and so many concepts involved. Let's find the antiderivative. It's going to be 8t squared over 2 minus 3t cubed over 3 plus 20t from 2 to 4. And then that's going to be 4t squared minus t cubed plus 20t from 2 to 4. Then I'm going to plug in 4. Then I'm going to plug in 4 again and 4 again. Then I'm going to plug in 2. And now it's just arithmetic. Let me lower my, whoa. Now it's arithmetic. Okay, I'm happy. This is 4 cubed, that's 4 cubed, that cancels. I'm left with 80 minus, that's going to be 16 minus 8 plus 40. I think I remember why this wasn't recorded. I think I messed up so badly that I just didn't do that. That's going to be 8 plus 40. That's going to be 48. That's going to be 32. Is that answer there? 32? Yes, hopefully that's the right answer. A lot of work, a lot of stuff just happened in that problem, but that's number 13.